Good afternoon, everybody. I'm Nick Segura with Charter Communications, and better yet, I'm part of the Rocky Mountain Chapter Board. Today, I would like to introduce you to a webinar that we're going to share. Very excited to introduce you to this, How to Test the Network Gen Cable Tech Cable Deck Board. But before we get started with this, I want to take you to some of the key chapter features for Rocky Mountain of the SCTE. Next slide. And some chapter business I want to share with you. The Rocky Mountain is recognized with several awards at the Chapter Leadership Conference. And I want to share these with you as a super proud moment for many of the chapter members and the chapter board leaders and assistants. We know the recipe, I feel, for becoming a top chapter of the world. And I'm going to share some of the thoughts with you. I mean, ask me why and how I would become chapter involved and best use my chapter for SCTE. And it's about the volunteer opportunities. Being the best chapter in the world comes by enriching the lives, the work lives and home lives of others through ongoing growth, development, and connectivity to their industry and to the community. Think about that mentor-mentee part of this. One of the things that I want to do before I retire is get as many people to understand the success stories that I've had to save them time and get them ramped up in their career to make more money and be a better person in the community. So that's one of the best reasons I would tell you to get involved in SCTE. And it's not about the rewards by itself, it's the rewards from the people that give you back a phone call. Hey, I enjoyed what you said. It got me further ahead. Thank you. Now I want to take you through some of the benefits of membership and just remind you to renew. But free trainings is a big one, such as the one today. Connectivity and access to amazing people in the industry. You know, who you get to bump elbows with is everything. You seem to pick up the most from the most influential people. And I could name the top 5 people in my career that boosted me the furthest, and I called them my mentor. Anyway, giving back to individuals for greater industry growth and success is another reason to renew your membership, to add your membership if you're not there, and don't forget to affiliate to the Rocky Mountain chapter. Your membership does not usually auto-renew, so make sure you check it out. You should be renewed by January to February timeframe. There's a place on the Comcast website here to go to, or through SCTE in a Comcast area. All others follow the right side of your screen to renew your membership. And let's go into a little bit about certification. Without saying it's a way to brag, right? How do you brag to your peers or to yourself? Prove your cable knowledge, gain the recognition for your skills, promote your expertise, overall advance your career. So get certified today. Don't forget that the Rocky Mountain chapter will, for any successfully passed exam, not only pay your exam fees, but reward you with an incentive. I've seen it $100 and more. The small print in the 4 bullets is that you must be an active member. The exam fee will only be reimbursed when you pass. Out-of-pocket exam fees are eligible for reimbursement only, and your incentive reward will be paid out one time per certification. Call me personally if you have any questions about certification. I would love to be your proctor. Right now, this series of certifications is like the most popular. It doesn't mean it's the only. In fact, if you're in the call center or billing finances, that was an area to get certified in, but these are popular from installer to advanced engineer. And let's get started. Today I want to introduce you to a panel of virtual people from a previous recording. It's Bastian from SCTE, Jim Walsh from Viavi, Griffin Ashe from the Edge Red Hat people, and Jason Rupe from Cable Apps. It was led by Alan Breznick from Light Reading, and we're excited to share this with you today. Before I go there, I'd like to remind you, go to Facebook, Twitter, send an email to scte@info@gmail.com. or go to our website for more information. So without further ado, I'm going to introduce you to the chapter replay today, and I hope you get a lot out of it. Thank you. Justin, can you kick off?
Just type your question into the Ask a
There it
Question
goes.
and then click the submit button.
Yes.
We will also
We're good.
offer up one audience poll today as time permits.
You didn't miss
So
anything.
keep things moving right along. And in that spirit, let's take a glance at our four main speakers today. After setting the context for today's discussion, I'll hand over the digital lectern to Jim Walsh. Jim is Solutions Marketing Manager for Viavi Solutions. He will join us from Indianapolis, Indiana. Our second speaker will be Griffin Ashe. Recently promoted, Griffin is now a Principal Solution Architect for Service Provider and Edge Computing at Red Hat. He will join us from the Denver, Colorado area. Next up will be Jason Rupe. Jason is also a Principal Architect working in the Wired R&D unit at Cable Labs. He will join us from the Denver area. I'm tripping over the actual name of the town. Okay, and then batting cleanup will be Chris Bastian. Chris is Senior Vice President of Engineering and CTO of SCTE, and sorry to say, also a big Philadelphia sports fan. Chris will join us from SCTE headquarters in Exton, Pennsylvania. So that is our speaking lineup today. Okay, so let's look at our agenda. As usual, we have a lot to cover. First, I'll do a brief overview about next-gen networks. Then Jim will come in from Viavi and talk about the 5 mores of next-gen networks. Then Griffin will come in from Red Hat and talk about network virtualization and its impact on testing. Then we'll have Jason from Cable Labs talking about streaming telemetry and proactive network maintenance. And then Chris from SCTE will talk about standards, programs, initiatives, and more that SCTE is doing. And finally, we will tackle your questions at the very end. Okay, so let's start by looking at the next wave of HFC networks. Let me just go through this build here. As you can see, some of the key new technologies that the cable industry is prepping for or rolling out right now. First, we have DOCSIS 4.0, of course, which is a new, more bandwidth-efficient DOCSIS spec designed to deliver multi-gigabit speeds, both downstream and upstream over HFC lines. Next up, we have a distributed access architecture, DAA. The idea here is to split nodes and pull fiber and some of the electronics that were once housed centrally closer to the home, cutting down on space and power requirements at hubs and head ends. Then there's XGS-PON, which is aimed at delivering symmetrical 10 gig speeds over fresh fiber plant, all fiber plant. And finally, there's fixed wireless access, or FWA, which pairs together HFC or fiber networks with new wireless spectrum to bridge the digital divide and reach households in rural and other unserved and underserved regions. Okay, so those are some of the kinds of new technologies that cable networks are getting ready for. So let's talk about the types of network upgrades planned. We'll turn to a couple data points from our latest annual survey that we do of cable operators and other wireline providers that we do in conjunction with SCTE. Among other things, we asked operators which types of network upgrades their company plans to carry out over the next 5 years. As you can see in this slide, the results are all over the board, but a few things stand out. First, nearly 2/3 of operators, or 62%, plan to deploy fiber to the home in at least some of their regions by fall 2026, which is a pretty impressive number. Second, nearly 2/5 of respondents, or 39%, said the company plans to deploy fiber deep in at least some territories. So there is going to continue to be a lot of new fiber installed in cable systems around the world, which should make the folks at companies like Corning very happy. Third, there is industry support for lots of different DOCSIS varieties. DOCSIS 3.1, which is already pretty much universally deployed, full duplex DOCSIS and extended spectrum DOCSIS, which are both part of DOCSIS 4.0 and low latency DOCSIS. Finally, there is also industry support for both fixed wireless access and DAA, as we just mentioned before. So the industry is clearly looking to move forward with a wide range of network upgrades over at least the first half of this decade and probably through the 2020s. Okay, one other data point that I want to highlight here from our most recent survey. In this question, we asked operators to choose the most important element of test process automation to add to their test processes and procedures. In this case, three choices came out almost evenly. As you can see here, an instrument-based guide to take techs through tests step by step, ensuring compliance with methods of procedure led the way with 25%, but it was closely followed by creating job task lists with all supporting configs delivered directly to an instrument, and a centralized management tool for both in-house techs and connectors, both of which came in at 23%. So there's a lot of different things that people see as important automation elements to add to the testing process, which I think Jim and Jason will go into more during our presentation. But for now, that wraps it up for me. So let's turn to our first speaker, a main speaker, Jim Walsh of Viavi Solutions. Good morning, Jim. Good to have you back with us again.
Great, Alan. It's great to be here.
Okay, take it away.
Okay, let me start my watch here to keep me honest on time. So,
okay,
yeah, so you had on the agenda item the 5 mores of next-gen networks. So rather than talking specifically about the individual technologies and architectures that people are looking at for next-gen networks, I'm going to look at it more from 5 aspects that are common across many of these, and we need more of all 5 of these in order to deliver the speeds and capacity that our customers are demanding from us. So the first one is more fiber. I think enough said there. More speed. So this isn't the speed we deliver to the customers, but the speeds we have to have all the way across our network to deliver the end speeds to our customer. We certainly need more nodes to shrink service group sizes to deliver the capacity that we need. To do this on the HFC side, we're going to need more hertz. We're going to need more spectrum both up and down to do this. And we're going to have to get more bits out of each hertz of spectrum that we have. So these are the 5 mores. There are actually more than this, but these are the 5 that I chose to focus on for today. So the first more is fiber. So I'm going to steal a little bit from Six Sigma methodology here and talk through the man, materials, and methods of fiber. Materials, really, again, enough said. We all know the supply chain's in a mess right now. Getting fiber, getting the endpoints is a big deal, but not a lot of impact on test for that. But man and methods definitely has an impact on tests. So manpower, we need people. We need to expand the workforce quickly. We need to bring people on board quickly, get them up to speed, get them producing quickly, both internally and from a contractor end, in order to deploy the amount of fiber that we have to deploy. And how that impacts test and how test can help is just by making the instruments, making test systems, making the whole test process simpler, more intuitive, so people can spend less time learning and more time testing. So I included a screenshot here of what a modern OTDR screen can look like. Rather than having a cryptic trace that you need a lot of experience to understand and interpret, make it simple for all these new people. So again, they can get out, they can be testing, they can see just what they need to see and move on with it from there. Closely dovetailing with that is the processes. So as we have all these new people being added, we have to have efficient, effective, repeatable, and auditable processes. And a lot of this lends to the automation from the previous survey of just making sure that we have the right instruments available, that they're set up right. The technicians don't have to figure out how to set these things up. The right tests are loaded, make sure that they run the right tests and everything passed before they move on to the next step. So these are some of the things that we can do to help make the fiber piece of it go smoother from a test aspect. More speed, again, this is not about speed for delivering to the customer, the end customer, but more about what's happening all across the network to deliver that. So back in the core, 100 gig networks were a big thing a few years ago. Now we're talking 400 or even 800 gig across the core. Metro's going 10 gig up to 100. Access network. A year ago, it was a really big deal, or 2 years ago, it was a really big deal to have 1 gig optical Ethernet out in the access network. Well, now that's 10 gig plus in order to keep up with delivering gigabit services as we go through muxes and things like that for the DAA nodes. So the test implications of that are just making sure that we have deployed tools that can handle this speed and make sure that everybody's using the proper methods. We should be measuring an end-to-end Ethernet stream across this network and not individual point-to-point connections, because that's what matters for delivering the services. We also have to know how to segment issues once they're detected. This is obviously a greatly simplified diagram, and there's a lot that can go wrong here. You can have misconfigured switch ports, you can have bad switch ports. AOCs, active optical cables, are out there now. those can go bad. Even something as simple as a bent fiber can cause issues. So we need to be sure that we consider the impact of the speed all the way across the network on test. So the next more is more nodes. And again, this is all about node splits, which are largely enabled by DAA today. And this is, again, all about shrinking service group sizes. And this, the left side of this slide is something I stole from a live learning webinar I did 2 years ago. And at the time, system maturity was the biggest problem. It was so hard when we were rolling these things out to figure out whether we had a physical layer problem in the network somewhere, or whether it was just something glitchy in the remote PHY systems. Fortunately, we're past that maturity curve with remote PHY, although we're stepping back a little bit as we move into remote MAC-PHY and FMA. But I also look back on that presentation, there were a lot of things we said, were going to be problems that we've developed solutions for, but new problems have emerged. And one of those is QAM video verification. So the challenge here is that with distributed access architectures, RF video is created for the first time out at the remote PHY node or the remote MAC-PHY node. So a lot of tests that used to happen back in the head end, or at least in the combining network, can no longer be done. It can only be done in the field. And so, there's a lot of things that can go wrong that the person out in the field can't fix, but they need to detect, like missing PIDs, stall PIDs, missing QAMs. You can have problems with the out of bands. So what we need is to make sure that the people in the field, one, can detect these when they turn up an RPD, and two, that they can know what the problem is. So when they go to do a handoff, it can be a clean handoff with groups they're not used to working with. They can tell them, here's exactly what I saw, just to end all the quabble of whose problem it is and make it simpler to get on resolution. So a lot of doom and gloom and a lot of challenges here in testing next-gen networks, but we can't forget about all the good work we've done to date. We did a lot of things, like I said, a lot of things we said were going to be problems that we've developed solutions for as an industry for remote PHY deployments to make it really seamless for technicians to move from working on legacy nodes to remote PHY nodes. And a lot of this foundation we laid for remote PHY will transfer directly into remote MAC-PHY and FMA. There's a lot of things that just absolutely won't change from a test perspective. I got to be careful on PNM. A lot of things are changing in PNM, the way we gather data, the way we analyze data. Jason will talk a lot about that later. But how the measurements work and how technicians leverage them, everything we did for remote PHY will continue to work in remote PHY. Upstream spectrum, sweep, how we set up amplifiers, PTP timing, Ethernet test, all these things that we do, none of these things will change and as we move forward to remote MAC-PHY. So it should be, again, a relatively seamless transition from a test standpoint in that way. The next more is more hertz. So this can be either in the upstream or in the downstream. In the upstream, it's split changes. And 2 years ago, that really meant mid-split, moving to an 85 megahertz upstream, but that's not really giving us enough bandwidth in a lot of cases. So the high split, the 204 megahertz, is getting a lot of attention. It's a heavy lift going to high split. You have to go off and touch all of the actives to do this. It's a lot of work just from the operational standpoint, but from a test standpoint, one of the things that creates a challenge is the things that used to be in the downstream, like pervasive FM ingress that's always on, is now in the upstream, as is the aeronautical band, which matters, in countries like the United States and others that have regulation in this area to be able to monitor leakage. So fortunately, instead of monitoring downstream signal tags or OFDM carriers, there's a method out there using upstream OUDP test bursts from cable modems. And some of the more modern leakage platforms can adapt and do this with the deployed hardware, just with software updates. So there is a solution there, but it is something that has to change. On the downstream extended spectrum DOCSIS, I hate to minimize this. Some operators talk about this as, hey, we've done frequency extensions in the past. This is more of the same. Yeah, it is, but there's certainly some challenges for amplifier vendors in getting this and characterizing spectrum. Full duplex totally blows out of the water the concept of upstream and downstream bands, way beyond the scope of my minute and a half or more to talk about this one. I think that's a good topic for future webinars that will be upcoming. So another opportunity that we have as we're going off and making these changes in our network is to revisit some things we used to do in the past. So for those of you old enough to remember wink switches, they were a great way to remotely segment upstream ingress. And the way they worked was you can go through and you can remotely pad individual legs of an amplifier and look at the spectrum and see what it does. So if you're padding a leg of an amplifier and the noise is passing through that leg, you would see the spectrum attenuate. Versus if you were to pad a leg that was not, that did not have noise going through it, you would see that the noise would not attenuate. So this way you could remotely isolate noise all the way down to a single amplifier leg. And if it was causing an outage, you could leave it attenuated, which would temporarily take care of an outage for you until you could fix it. This didn't take off in large scale because you had to go off and touch each amplifier to install these switches. And you also needed some type of system to control them. And hey, now that we're going out and we're potentially going to be touching all these actives, and the major vendors that that the industry is using for high split and for extended spectrum DOCSIS, pretty much all of them offer this option now. Plus you have control of these being integrated into return path monitoring systems and similar. It's a great time to take a look at another look in an old technology. The last more is more bits per hertz. So this is OFDMA in the upstream. And lots of great discussion at Expo about this, about how we've just scratched the surface, how PMA applications and artificial intelligence and machine learning can help here. But some of the test challenges this creates is the really wide OFDMA carriers. It makes it hard to see ingress using traditional spectrum techniques. So a lot of operators have adopted things like heat map types of spectrum, either in return path monitoring and in their field meters, to be able to see even bursty ingress popping in under these carriers. And sweep is also a challenge, not being able to place sweep pulses between 6.4 meg wide upstream carriers. Well, now there's solutions that allow you to sweep right through OFDMA without any impact. So takeaway is you can get a lot more out of OFDMA, more bits per hertz, and especially what I'm showing on the right chart here is if your plant is clean and tight, if you can increase your SNR by only 4 dB in the upstream, you can get 50 more megabits per second out of a 31 megahertz OFDMA carrier. So keeping your plant clean and tight is still important, even in OFDMA environments. So the last slide, excuse me, just inspiration that, hey, this can be done. This screenshot is a year old from a European plant where they're actually getting 2 gig down and 1 gig up using today's technology. And actually you can achieve 4 gig down and 1 gig up with with technology that's deployed today. Plus, we have a very robust roadmap ahead for the HFC to make sure that it remains a strong option of choice for future broadband provision. That's it, Alan.
All right, great, Jim. That was very comprehensive. Thanks for getting us started here. Now let's turn to our second presenter, Griffin Ashe of Red Hat. Welcome back to the live learning series, Griffin.
Hey, Alan. Thank you for having me.
Sure.
So today I'm going to talk about network virtualization and the impact it can have on testing. Network virtualization means moving to more software-centric environments. For example, this can be thought of as the evolution from vertically integrated appliances to VMs to containers. And you can look at this evolution as a journey, and cable operators are going to be at varying stages throughout that journey. For example, phase 1 and phase 2 focus on infrastructure modernization, where the emphasis is on cloud management platforms and how to orchestrate things at the NFVI layer, and then into the harmonization of common platforms. And then phase 3 and phase 4 focus on application, where the emphasis is on more cloud native and moving to elastic and very distributed architectures. And a key element throughout all of this, regardless of what stage you're at, is automation. And there is most likely going to be increased levels of automation as you move from one stage to the other, moving from left to right on the diagram here. If we take a deeper look at what increased levels of automation allows for, there are 6 common use cases we see that can be applied to a wide variety of network devices, applications, and infrastructure environments. But if you take a step back, the goal here is to provide consistency in how you operate. So if we take orchestrate, for example, you want to make sure that a service chain comes up in the right order. When we manage configurations, it means knowing that commands are going to execute predictably. When we deploy applications, you want to know that they are going to be properly discoverable by other services that they depend on. When we provision, it means knowing that a workload is going to spin up in the proper location. When we deliver continuously, it means proper testing is done each time. And to secure and comply, it means knowing with some level of confidence that you aren't as exposed as you were before. Once you have a foundation of software-centric environments paired with automation, you can start to see how this can be applied to testing and monitoring. Tighter feedback loops, for example, if there is a service that goes down to the network, you can not only be notified of the issue, but have active steps taken to remediate it. If you need to spin up a workload to prove something out and maybe reproduce an issue at the network or application layer, not having to rely on the provisioning of hardware each time is a huge benefit. And hardware is important, though, for performance. So if you want to test a new NICS throughput, for example, you could have a requirement for a new driver. Installing that driver manually across all the servers in your lab can be very cumbersome. This is a very simplified HFC network, and this is work based on a cable operator we engaged with over the past year or two, and we've all seen diagrams like this before. While it looks oversimplified, that's kind of the point. We wanted to get to a state where things started to look really cookie cutter and repeatable. So this deployment has its origins in the lab. It's modeled in software. It's tested over and over again and executed with the help of automation. So when it comes time to roll this out into production, we know what we're going to get. There's a certain level of predictability and repeatability to it. And this reinforces that theme of consistency. And that's really what we're trying to achieve here. Consistency of operations enables better testing, moving to a model where our platforms and our technologies are predictable from the initial development of an app or service all the way out through production and ongoing support. So I'll keep it brief today and keep things moving. So I'll throw it back to you, Alan. I'd like to thank everyone for the time.
Okay, thanks very much, Griffin. Excuse me for not coming back on camera, but it's just easier for me to do questions, which we're going to get into in a second. But excellent, thank you for the network virtualization talk, and then I know we're going to have some questions about that later on. So let's move on to our first and only audience poll question of the day. Here it is on the screen. It's a new version of the one that we did as part of our SCTE survey. Which types of network upgrades does your company plan to carry out over the next 5 years by fall 2026? And we give you a bunch of choices here. We give you 7 altogether. Please select all that apply. Deploy DOCSIS 4.0 is the first choice. Second choice is to deploy fiber deep. Third choice is to deploy low latency DOCSIS. Fourth choice is deploy DAA. Fifth is to deploy fiber to the home. Sixth choice is to deploy fixed wireless technology. And the seventh and last choice is to deploy XGS PON. Now, it'll take the ON24 system a minute or so to compile all the results. So while waiting for them, let's bring back Jim for a quick question. Jim, are you with us here?
Yeah, I'm here.
Okay, great. Jim, what are your customers looking at to deploy right now on, and how many of these things are they looking to deploy? Is it, are they primarily looking to do 1 or 2 of these, or everything?
Yeah, of course the answer spans the globe there as far as what they do, but yeah, certainly no one's looking at deploying just one. And right. You know, when I talk to customers about this, it largely makes a lot of sense what they deploy. You know, things like, hey, we plan on deploying fiber deep as part of our DAA. As we're putting out DAA, it's not just a one-for-one. We're pushing deeper at the same time. Or, hey, we're deploying fiber deep in preparation for selectively deploying PON where it makes sense via remote OLTs and things like that. And we also see things joined at the hip, like, while it's not on this list, high splits. We sometimes will see people making split changes the same time they're doing DAA to merge the two construction projects together. So which ones they combine largely is dependent on what their end state is and what makes sense as far as the path to get there.
Okay, all right, thanks. Let me try to get the results up on the screen here. Had a little trouble making that happen. Let's see what I can do. Becky, maybe you can help me get this up on the screen? Okay, there we go. All right, thanks. So let's see. The leading choice here seems to, it's pretty even between deploying DOCSIS 4.0, deploying DAA, deploying fiber to the home, all in the mid-20% range here. And even the XGS PON gets a significant percentage. So it looks like cable operators are hedging their bets, looking to do a bunch of different things, as you mentioned, Jim. Anything stand out to you here? Anything surprising to you? Or is this what you would have expected?
No, it's very similar to the last one as far as proportion. The scale's different. You have much lower percentages. There must have been a glitch in the poll because they all add up to 100 last time, and it added up to way over 100 last time. So apparently people can only select one this time.
Yeah, looks like we weren't letting people take multiple choices, so I apologize. So that'll be interesting. Next time we'll try and we'll give people up to 3 or 4 choices to select. So,
but the proportions align. It's funny. The proportions align just about exactly the same as last time.
Okay, yeah. So things haven't changed that much in the last year. Okay. Well, thank you, Jim. Thank you, Griffin. Next, we're going to move on to our third speaker, which is Jason Rupe from Cable Labs. So, Jason, thanks for joining us from Lafayette,
Thanks for inviting
Colorado.
me. Thanks for inviting me. Looking forward to this. I'm going to breeze through a few concepts related to the great foundation that our first 2 speakers laid out for us. And hopefully it'll all come together in a nice picture by the end. And you'll see that while the future is challenging, it's also one that I think we're going to be well prepared for. And I think the outcome will be very good. And certainly in life, we have more than one choice we can make in terms of our architecture, but that leads to some complexity, and that complexity is something that I'll talk a little bit about. And so, if you're going to run a network, you got to be able to test it. You need access also to therefore all the telemetry and the information coming off those network elements and how to pull that together into a view of what the behavior of the network is. So I'm going to try and talk about those topics a little bit. First, the concept of streaming telemetry. I want to talk about this concept first because this is fairly new to our industry. And these are techniques for data monitoring where you get operational data streamed from the network devices. We're kind of in a SNMP, TFTP, and when it comes to CCAP cores, oftentimes we're doing screen scraping to really pull the information off the network elements and be able to support the operation systems. In the future, and this future is now for many operators, you're going to be able to get data monitoring in a streamed approach. And what that means is that you're going to have some models that you can subscribe to. And those standard models you can access by many different choices, as we'll talk about here in a second on the next slide. And you've got a lot of these options are being provided by OpenConfig, and that's a part of IETF. And the mechanisms that the industry here is starting to gravitate toward are protobuf encoding with gRPC protocol. And what this is going to allow you to do with applications is subscribe to selected data elements off the network and get that device's data model from that through a subscription. And you're going to be able to do that in a couple ways. You're going to be able to get a constant stream. So that's going to be useful for periodic or a sort of over a sample interval. And that's going to be really good for frequently changing data, like statistical counters off of the data plane. And you're going to be able to get telemetry data based on maybe a change in what has happened in the network. Whenever there is a change, it's going to give you information. Those two approaches, I think, are going to cover a lot of options, but the advantage being that you're no longer going to have to do a poll of the data. It's going to be, I want this data, you subscribe to it, and you're going to be able to get that data until you say, stop, I've had enough. And that means you can set things up and kind of operate with them going forward without having to set up polling. So you'll take a look at this presentation here. This is information pulled from ONF, but we've rebuilt it here to kind of give you a view of what the options mostly are. We're going to have Yang modeling at the core. That's going to allow you to do a lot of different things here. But the industry, our industry in cable, is really gravitating toward one set of solutions. And that is, we're going to go down this right-hand side here where you've got protocol buffers, protobufs, and that's going to provide your Yang data schema and also provide your data encoding. And then you're going to be able to access through GNMI, gRPC-based solutions to get your configuration. Your API is going to be formed in that mode. You're going to have all those other options, by the way, if you want to be able to go down that path, but you can count on what you're seeing here as being provided, because that's where the spec is going. And what that means is you're going to have Yang models to provide the hooks into the data for the network data elements. You're going to be able to use a Yang push to be able to stream or to get the data on change. And you're going to have all these as key elements in all the DOCSIS 4.0 solutions and the architecture choices around that, around DCA, including Remote PHY, flexible MAC architecture. All those will be sort of baked into that. Now, as we kind of look forward into PNM, of course, PNM being proactive network maintenance, it's really network maintenance, and it's really network telemetry involved, because to be proactive, a lot of times we use the same tools to be reactive, but to be proactive, we really need to understand what's going on in the whole network. So really, it's not just the traditional PNM tests that we often count on, but there's a lot of other telemetry that's going to fold into that decision making. And PNM really is about intelligent decision making, because you're controlling your operations costs, and you want to be very intelligent and smart about that. So as we develop PNM for, say, flexible MAC architecture in the future, we're improving on a lot of the methods for the data acquisition and the bulk data transfer methods to get the data off of those CCAPs. Today, it's kind of a challenge, and you kind of got to work out piece by piece, because there's not a lot of consistency in those options. But we think we've got new approaches which are going to help it to be easier to be consistent. And that's where I think things are going to really improve and make things easier for you to do a lot of the FCAPS functions that you need to do, but in particular, fault management. And these new methods are really being grown on a stronger foundation. In order for us to do, say, the FMA work, we established a Task Force 5 focused on PNM. And in looking for how we need to do FMA, we realized we needed to kind of strengthen the foundation a little bit. A lot of the older spec texts were not aligned perfectly, were not aligned as clearly as we wanted. So we said, you know, if we're going to do this, let's do it right. Let's put in the energy. Let's strengthen that foundation. So we did a lot of alignment. And what that ended up doing is actually creating some new options for DOCSIS 3.1 as we went as well, not only the DOCSIS 4.0 specs, but as we clarify the existing specs, we created a really strong foundation for DAA, FMA, all the sort of flavors of DOCSIS 4.0. And as a result, we have a good approach that's going to be Yang-based, GNMI supported, and more options going to be possible for that. We're right now at the phase where we're about to issue phase 1 solution. So we're going to close on all the discussion around phase 1. Phase 1 is where we are going to have FMA support all of the legacy approaches and legacy methods for data acquisition and the new methods. And then in phase 2, we're going to move to a fully streaming telemetry solution, allowing everybody to kind of use the approach they want to grow into the new approaches for data acquisition and to grow their solutions. That's going to be much more efficient for network data acquisition, but everyone's going to have plenty of time to get there. At the same time, the cable modems are going to essentially stay the same, but we have USP part of TR369 that's really going to create that next generation data acquisition approach too. That's not going to spell the end of everything, of course. You've got lots of things going on the optical side. You've got a future where you're going to have IoT involved. So that's not going to be the answer for all, but we see as a lot of these things coming into more of a streaming approach and a next generation data acquisition approach. So the future is going to be much more efficient to get there. Meanwhile, in the P&M world, we're working on new tools and techniques. I would say we're applying really more of the science to P&M. With the combination of SCTE and Cable Labs, which has happened this year, we were able to enlist an approach, the DevOps approach, into P&M, which means that as we work with the field folks on certain aspects on the SCTE side, we can work on the specifications, we can work on the tools and techniques on more of the R&D side that Cable Labs does. As a result, I'm showing you sort of one example here, this water wave example. We've accomplished this year, and it's really part of that DevOps thinking. So as we find things in the field, we don't just work on them and say, how do we improve the field ops? We bring that back into what does this really mean in terms of P&M? Do we have the right information? How do we make use of the information? What kind of tools do we need to make use of that information? And in an SCTE paper we published at Expo this year, and in some material that we're going to publish here very shortly in a primer for P&M best practices for DOCSIS 3.1. That's going to come out in January. You're going to see more information about things like this. But we were able to codify a lot of what you can kind of see here. In the two pictures, you can clearly see a difference, but we're codifying that and making that a part of what you can automate. And we've got some new tools and techniques that we're going to publish in there. And the interesting thing about this is we really learned from that process that we can do a lot more of this. We're going to use this success to replicate that and bring a lot of new science into P&M in the future. And that's coming at a really good time, as I think, as you'll see. So we're going to take this to the next step to understanding spectrum analysis. That's going to be an SCTE report coming out here shortly, probably early next year. And our next effort is really around failure modes, effects, and criticality analysis thinking, where we're going to look at the overall access system and look at and build what we're calling a repair matrix, but it's really going to be an end-to-end thought in terms of here's what can go wrong with the network, here's how we understand how that happens remotely and how we can do that from a testing and telemetry perspective, and then what does that mean to impact on the customer so we can make decisions on what to do, where is that in the network most likely, what decisions do we make for maintenance so that all these things can be linked together, and you as an operator or you as a vendor can help manage the costs around that. That's where the real advantage is going to come. So meanwhile, Cable Labs is also doing a lot of work to build some tools and techniques to help vendors get started on some of this and operators. We have our ProOps solution. The picture on the left side is really around turning data into action. We had created our common collection framework as a foundational framework, and then we built the full stack framework on top of that. So you can turn all that data into action, and it's really a flexible architecture which allows you to test out theories and concepts. You take any sort of intelligence you want to create, you put it in as a worker in the environment, you schedule in the environment how often that gets executed on what data elements and what data network elements you want to do and whatever schedule, and the rules go in there to help you turn that into action. So you can test theories and all of that. So it's out there so all of us can really do R&D. At the same time, we're creating this new data labeling tool that we've offered out to everyone as well, because we really see that machine learning is an emerging technology here, and we've got to help develop it. But our latest wisdom over the last 2 or 3 or 4 years that we've been working on it is that it's really a complement to the rule-based solution. So we've got to develop all of that kind of together. And so we've developed this tool, and we're finding that it's useful not only for training machine learning, but also training trainers and training technicians and training anyone who wants to understand how to do this. So you can fold in solutions from your anomaly detector that get automatically labeled. You can show that compared to what you think the answer is. You can put answers in there from an expert, share it with others, and we all get to learn together. It's been really a good experience. And we're going to take this to the next level and allow these bin data to inform where likely it is in the network too, because we think really machine learning is going to help us make determinations as to how to make a decision to help the technicians out there really troubleshoot and solve the problem most efficiently. So as I think you've seen now and would see through all these presentations, the future is going to be optimized. We're going to have all these capabilities and solutions to be able to really get at the problem, be really efficient with our resources, but at the same time, these new technologies are coming with DOCSIS 4.0 and new options. And because of that, there's going to be new new things to manage, like we now have more latency. We have latency measurements to deal with. We have new echo canceling technology. We've got profiles to manage. We got leakage detection and all of that. And so as we kind of go forward, we're enabling all this new techniques and new solutions, which will lower cost and provide more capability and more reliability. At the same time, we're going to take advantage of all these new data elements and new data approaches to make sure that costs are optimized and the network gets optimized and your operations are as well. And that's with that. Let's go out and invent that future.
Okay, excellent, Jason. Thanks for digging into streaming, telemetry, and all the related technologies for us. That was excellent. Okay, now it's time for our SCTE closer, Chris Bastian, fresh from his season with the Phillies. Welcome back, Chris. We missed you.
Thank you, Alan. Just audio check. Sound good?
You sound great.
All right. Thank you. Thanks for inviting me back for this monthly webinar. Always happy to do these and coordinate with you, Alan. So I just wanted to provide a quick overview of the SCTE standards program. So the program is organized into 5 subcommittees: network operations, energy management, interface practices, digital video, and data communications. To date, the program's produced over 300 standards and operating practices, all dedicated to the cable industry. And all of this approved documentation, the standards and the operating practices, are available for download at scte.org/standards. We currently have over 140 companies already participating in the program. And basically my net out of this discussion today is I want to encourage everybody in the audience to consider joining in to create these standards and to basically drive the direction of technology in the industry. So we've had a special focus the past 2 years. We've launched several new working groups under the umbrella name, the Explorer Initiative. They've all been very active groups, some of the most active groups that we have. The program overall has over 30 groups, and these 5 groups have consistently, week over week, been some of the most active. So we have aging in place and telemedicine, smart cities, artificial intelligence, extended spectrum, which I'll dig a little more deeper into in the following slides. They're all mature groups at this point. They all have established objectives and deliverables that they've volunteered to sign up for delivering that documentation. And we're right on the verge of launching a brand new working group focused on network and service reliability. And as the working group name implies, it's going to look at both layers, both the network layer and the service layer, to ensure that we are delivering end-to-end the services in a reliable fashion to our customers. So if that specific group, since we're really just in the right on the verge of launching that group, if that's of interest to you, please reach out to me and I'll get you read into the group. So the standards work that the program focuses on directly applies to the rollout of the 10G platform. And I've listed here, I won't go into all of them, but I've listed here some of the initiatives that we have that are going to directly influence the success of the 10G rollout. Under reliability, we have network powering under the energy management program. Jason referenced the proactive network maintenance, that's under network operations. Jumping down to security, we have several projects with artificial intelligence, machine learning working group that will focus on security. With speed, again, I'll be going a little into more detail in the following slides on the 3 gigahertz actives and passives, as well as the generic access platform. So there are, the 10G was announced about 2 years ago, the path that the industry is on for launching the 10G platform, and the standards work is directly applying to the successful launch of that. So going to the next slide, we have 2 working groups focused on supporting extended spectrum. The 3 gigahertz task force, which I just mentioned, it looked at all the existing cable standards that reference spectrum and that group recommended how best to update the existing documentation to support 3 gigahertz. And a separate working group looked at the 1.8 gig as well as 3 gig hardline taps and passives, and as a result, they issued 2 standards. SCTE 264 focused on the hardline taps, and SCTE 265 focused on the hardline passives. And again, just a reminder that if any of this work specifically interests you, that all the standards that I'm referencing are available for download at the website. So ongoing work that we have is focused on the 1.8 gigahertz amplifier. The work will provide prospective equipment vendors with the guidance to design and manufacture standardized products to support full utilization of DOCSIS 4.0 in the network. And I have listed here some of the names and companies that are currently leading that activity. And then we have yet another working group that's just getting launched, which I would encourage your participation. The Smart Amplifier Communications will define methods to actively communicate with next-gen amplifiers and will be applicable for both the extended spectrum and the FDX amplifier work. So it's going to, we're basically looking to come up with a common protocol that would apply to both of those DOCSIS 4.0 approaches. It would also be applicable for standalone amplifiers as well as for launch amplifiers that are embedded in the fiber nodes. So we just identified the working group lead for that. Our close colleague over at Cable Labs, Doug Jones, is going to be leading up that work. So, and the last one I want to reference today is the generic access platform. This work kicked off a little over 2 years ago with the goal of standardizing the outdoor fiber node enclosure. So it's standardizing the physical, the thermal, the mechanical, and the electrical interface for the internals that go into that node housing. It's basically looking at completely standardizing the clamshell so that all of the innovation and the evolution of the network that the vendors are focusing on, that they can just take it for granted that the enclosure is standardized, and they're looking to optimize the modules that they're preparing for insertion into the node. So a major milestone was reached very recently in this program that 2 specifications were released. The -1 specification looked at the overall enclosure, and the -2 specification release looked at the modules inside the enclosure. So just wanted to summarize here rather briefly, just a snapshot of some of the work that's going on in the SCTE standards program. And I want to encourage you all again, if any of this work interests you, please reach out to me, and we would be more than welcoming to include you in the ongoing activities. So with that, back to you, Alan.
All right, thank you, Chris. And you'll be glad to know that we already got somebody who's interested in the reliability program, which you'll see in the audience Q&A when you look at that. But thank you for that. And thank you for the fresh slides and bringing us up to date on what SCTE is up to. So now it's time for take your questions from the audience. We have a couple of questions that have come in. Excuse me for not being on video. It's just easier for me to read the questions when I'm not on camera. Okay, so first we have a question from Jim for you. Are there any common themes that you've seen among how operators have prepared for 204 megahertz upgrades?
Yeah, that's a good question. So there aren't a ton of people that have been all the way through the execution so far.
Right.
We do tend to see that the Europeans were way ahead of the North American folks on this, although we are seeing the North American folks catch up. But yeah, we worked with some of the early adopters, and so much of it was about basic blocking and tackling. And you know, an example is focusing on FM ingress. So FM ingress, you know, it's prevalent, it's everywhere, just because, you know, in order to have an ingress issue, you have to have a shielding weakness in your network, and you have to have a noise source. With FM ingress, the noise source is always there, it's always on. So it's a pervasive problem in the downstream, but it's at the low band of the downstream, and some people even, you know, avoid that spectrum where they can afford to. But focusing on it while it's in the downstream is much easier than when it gets into the upstream, because you don't have the funnel effect. So you can focus on it both from a home standpoint, looking at the ingress scans from your meters and things, and even going back through and looking at past ingress scans that were passing but were near the edge. Go off and fix those first. Make sure you have tight installs, do your pressure testing of homes and things like that. And for the plant, PNM is hugely valuable here with FM ingress detection from full band capture modems. Again, without the funnel effect, you can get pretty close to where it is just by looking at modems affected by it and modems that aren't affected by it. Go out, fix it, clean it up while it's easy before it becomes part of the upstream. Other than that, just generally, CLI activities, focusing on leakage, making sure that your plan is tight, that everything's clean. Shortly after they deploy, make sure you do things like return sweep as part of your turn up process. So when the construction's done, if you have construction, or even if you're just switching a diplexer, then make sure that nothing unusual has happened in your spectrum response for that. So basic blocking and tackling, nothing real surprising other than just the amount of focus people put on FM where applicable to make sure that band is clean before it becomes part of the upstream.
Okay, thanks, Jim. Griffin, we have a question for you. The question is, what does the next generation of virtualization look like?
The next generation, the immediate next generation of virtualization will be environments that support both VMs and containers at the same time on the same operational substrate. Customers today and operators that we deal with feel a lot of pressure to go all in on containerization and feel like they have to abandon their VMs or else they aren't keeping up with the industry. With projects like KubeVirt as a part of Kubernetes, you have the ability to support all of your existing VMs while allowing for new apps that are containerized to be developed and run. So I don't know if it's, you call it the next generation or the step before the next generation. I think it's a bridging the gap between full-blown microservices architecture and where we are today in the form of VM-based appliances, taking that step between.
Okay, thanks, Griffin. Jason, I have a question for you. With the streaming telemetry and other things that you presented there, is there anything there that requires any kind of spec work or standards from Cable Labs perspective?
Yeah, sure. Thanks for the question. And yeah, there's a lot of spec work involved with that. So John Schnorr runs the Yang Gang, which is where all the sort of Yang discussion is happening in support of all of the DOCSIS 4.0 specification work. It's really feeding that. Part of FMA that's a key part of FMA, and part of FMA was to tackle the problem in pieces. So we have these task forces.
Right.
So we have a group focused on some of the telemetry aspects, which is linked to OSSI. There's a linkage from one of those groups into PHY. There is a group that's deciding the mechanisms for carrying a lot of this information, and the PNM group, of course, that I mentioned. And so there's a lot of spec work that's been going on and will be going on to ensure, I think, that a lot of these elements will be reliable. That's going to be key to be able to rely on the information to come off. We struggle with that a little bit at times, and we really have our eye on that ball to make sure that that what we do, make sure the information is reliable so that the networks can be.
Okay, thanks, Jason. Let's go around the room and ask everybody, when we do this webinar again a year from now, what will have changed? What will be different on November 2022? Let's start with Jim and then go to Griffin, Jason, and Chris.
Wow, a year from now. I think FMA will be much farther along. There's just so much potential there and I think that we're reaching that critical mass now, that the spec work's been done, everyone's been developing it, we're moving towards the deployment. Things like PNM are building around it. So I think it's going to be a big deal. I think PON is going to continue to grow rapidly, via native PON or via remote OLTs. I think we're going to be talking more
Right.
about that, more about people going XGS PON potentially as well. So I think those will, if I had to pick two, those would probably be the two that I think will be getting the most attention a year from now.
Okay, I appreciate that, Jim. I'm sorry, I know I put you all on the spot with this one, so thanks for going first on that. Griffin, what do you think will be different a year from now?
Alan, I lost my connection, just came back and missed the past, I don't know, 2 minutes of what the discussion was. I apologize.
Oh, okay, that's okay. I'll come back to you.
Sure.
The question is, what will be different a year from now on the testing and monitoring front? So I'll go to Jason and Chris and come back to you. So
Sure.
Jason, what do you think will be different a year from now?
Yeah, I really like Jim's answer. I think he's right on that. I think there's going to be a lot more deployment of optical technologies. Fortunately, PNM will come along with that, and we've been working on a lot of PNM, bringing the PNM concept into the optical side of things as well. So as that becomes more prominent and we have more PON, we're going to have the same capabilities. They're going to be very similar to support the cable industry so that technicians don't really have to change their way of thinking too much, that they can really rely on the same approaches that they've had. What I think is going to come out even more a year from now is you're going to have more science around how to do maintenance, because we're really starting to tackle that, I think, pretty well. We're gaining momentum on that. And a year from now, we'll have a few more really key elements that are going to help you understand really a tighter linkage between what you can get from the information from your network into what's the right action to take. And I also think you're going to see more prominent and more prevalent, easier access to the data that's going to feed all of that. And we're going to have to build some tools around that, how to manage that data. So I think you're going to see more of that. There's going to be a lot of really good vendor tools coming out that are going to be very consistent and help these operators move into this new world. I think a lot easier, and with I think in a lot easier way to manage even the cost side of that. So I think a year from now we're going to see a lot more of this adopted.
Wow. Okay. Thanks, Jason. So, Chris, besides the Phillies World Championship, what will be different a year from now?
Well, that's just a given. No,
Okay.
No, I want to put a plug in for DOCSIS 4.0. I think it's going to be a big year for the continued evolution of the, you know, the spec has been completed. So there's going to be testing, interoperability testing, more silicon work, more adoption in vendor equipment. So it'll, you know, it won't be ready for deployment, but it'll continue on those steps for significant advances in testing and interoperability to get it to a deployable stage.
Okay, thanks. Griffin, you get the last word.
Yeah, my hope for next year is that we are a lot further along on things like predictive maintenance and automated based testing backed by AI and ML. I know there's a lot of jargon that gets thrown around in the AI ML world, but I think that with the predictive maintenance and automated testing, I think it's a potential opportunity for low-hanging fruit for us to make significant progress between now and 12 months from now. So I'd like to see a lot more progress coming out of that. And, you know, we're doing our best we can to push that ball forward here at Red Hat.
Okay, all right. Thank you all, gentlemen. Well, I'm afraid we've run out of time, but I want to thank you all out there for attending, and special thanks to our four main speakers, Jim Walsh of Viavi, Griffin Ashe of Red Hat, Jason Rupe of Cable Labs, and Chris Bastian of SCTE for sharing their own live learnings with us today. Let's give them all a huge virtual hand. This webinar will be archived on the Light Reading website for the next year, starting early next week, as well as on the SCTE membership portal. Within the next 24 to 48 hours, you should receive a personalized follow-up email and with details and a link to today's presentation on demand. So feel free to review the webinar whenever you'd like over the next 12 months. This webinar is copyright 2021 by Light Reading. The presentation materials are owned or copyrighted by Light Reading, Viavi, Red Hat, Cable Labs, and SCTE.
Thanks everyone for attending. This concludes our webinar for today.